great. Okay, so we are going to learn about, of course, continuity and differentiability, the topic chosen by you, right? Am I correct?
Sir.
Okay, great. So do you have like any prior knowledge about this chapter or anything, or like are we going completely from the beginning?
So we finished it in school, sir.
Okay, you finished it in school, so I think that would be a quick revision type of that. Okay, but I assume that you might be not familiar with that, so we'll just go in a very funny and I would say very interesting way. So let's start,
Yes, sir.
shall we?
Yes, sir.
Okay. Okay, so first of all, anything before understanding any chapter, we must know like what all concepts we should already know before starting. Am I correct? Right?
Yes, sir.
Right? You cannot do multiplications of 2 digits without learning addition, right? So in that way, so we should have a little bit of knowledge about limits. So do you know anything about limits?
So a range of values.
Yeah, so limits basically range of value. Okay, can we make it in a more simple term, like something that we might remember for our lifetime? Shall we? Right?
Yes, sir.
So I'll just try to explain your limits in a very very short and I would say simple way. Okay, so like suppose if I'm getting very close to 1, okay, so this 1.000000001, right? It is very close to 1 but not 1 actually. Am I correct? This does it that I've written over here?
Yes, sir.
Right, Sandra? Right. So what we'll say that suppose this is our x, right? So we'll say that this x is very close to 1 but not equal to 1. Am I correct?
Yes.
So this is the limit. Okay. In practical life, like if you see, you walk towards a wall, right? You will reach to a certain, I would say, distance from the wall, but because of atoms and space, you won't be able to touch it completely. Are you getting my point? So you are very close to the wall, but you can't touch it. Are you getting my point?
Yes,
So that's a limit. Are we clear?
Yes, sir.
Sure.
Yes, sir.
You're not getting bored, right?
No, sir.
Okay. So then the next thing is differentiation. We have learned differentiation. Okay, right? Am I
Yes, sir.
correct? Shall I test a little bit knowledge of yours? Is it fine? You won't mind it? I hope.
Yes,
I
sir.
hope, right? Okay. So this is the formula, right? Dx to the power n, and then it is being differentiated with x, right? So what will be the answer? Can you tell me? Like it's just a formula, right? You know that, right?
Yes, sir. Nx raised to n minus 1.
Great. You are proving that your maths is your favorite subject. That's pretty good. Okay. So yeah. So you basically know about differentiation actually, like in mathematical terms at least. Am I correct?
Yes, sir.
Right. So differentiation is nothing but when we calculate at what rate something is changing. That is the practical application of differentiation, right? Okay. So great. And do we know anything about functions, Sandra?
Yes, sir. A bit.
Okay. So can you give me an example of any function, any random function? I won't mind it.
So f of x is equal to x square.
Right. This, right?
Yes, sir.
Correct. Absolutely fine. Right. So what are functions basically? Some kind of polynomial or any type of equation in which we put some value of x, right? And we get our value of the function. Am I correct?
Yes, sir.
Right. And after this, we just need a little bit of patience and a little bit of concentration, right?
Yes, sir.
So shall we start with now our actual topic, right? That is limits. But yeah, so what is our objective, right? Like what are we going to actually learn this chapter? You already know what we have learned because you know you have covered this in class, right? Am I correct?
Yes, sir.
So we're going to learn about what is continuity, what is differentiability, and what is the relation between both of them, right? Like if a function is continuable, like continuous, will it be differentiable as well or not? Am I correct? Right?
Yes, sir.
So we are going to learn about that, right? My voice is completely fluent, no breakage or anything,
No,
right?
sir. Nothing.
Okay, great. And then we are going to learn about inverse trigonometric functions and how are we going to differentiate them, okay? And we will also learn some new kind of functions called exponential and logarithmic functions, okay? So this is the objective of this chapter. Are we great? Are we clear?
Yes, sir.
Right? And since maths is your favorite subject, I don't think we need to explain this. So basically, just like pictures speak more, I would say 1,000 words more than what a text would ever, right?
Yes, sir.
Correct? So like, yeah, so milk when, for x, it shouldn't be x, it should be t actually, right? So when milk is getting heated with time, right? At some rate, it will be formation of cheese. Am I correct? Right? And if we add small milk, it actually comes from a cow, right? So this is just differentiation and integration, just a fun, okay? Okay, so finally, we are starting our topic that is continuity. Shall we?
Yes, sir.
Now I'm actually starting it, okay? Right. So our topic is continuity. Okay, so what do you understand by continuity? Let's leave maths for a particular moment of time, okay? And let's understand what do we mean by continuity. Can you tell me, Sandra?
So something that is continuing on without a break.
Exactly, something that is continuous without a break, right? No break, no kind of gap is there, right?
Yes, sir.
Correct. Okay, so let's I would say this is a function, okay? Fx is equals to, like, when values of x is greater than 0, I would say less than 0, then it is 1, and when it is greater than 0, it is 2. Okay, fine, right?
Yes, sir.
Okay, so I'm so sorry. If the board would have been working fine, I would have made a better straight line, but fine. Okay, so can we plot the graph of this particular function? Shall we try?
Yes, sir.
Okay, this is my x-axis, this is my y-axis, right? Okay, so when less than 0, like suppose negative of 4, is it less than 0, Sandra?
Yes, sir.
Right, so what will be the value if I say f minus 4? What will be the value? Can you tell me according to this statement?
So 1.
Great, so 1. So I will you know the plotting of the graph, right?
Yes, sir.
So I'll just plot it here, correct? Right? Okay, and what about f of negative 1? Still it will be 1, am I correct?
Yes, sir.
Great. Okay, what about f of negative of 0.000000001? What will be its value, Sandra?
So still 1.
Still 1, correct, right, absolutely right. Okay, so this is actually our concept of limit is getting used slowly. Okay, are you getting my point, right?
Yes.
So this is actually left hand limit of 0. Okay, we'll understand it in a little bit more detail. Okay, fine, right? So this is our 0 point, right? But we are not actually touching 0, did we? No, right?
No, sir.
Are you getting my point? But just before 0, what was its value? Its value was, so I'm doing this and I'm making a blank. This is not filled. This circle is not filled, right? Because we are not taking it at 0. Are we clear? Are we completely clear?
Yes, sir.
No doubt still
No,
now?
sir.
Sure, Sandra. See, any kind of difficulty. I know maths is your favorite subject, and you might not be facing any kind of doubts. But even if the smallest of the smallest doubt is there, right? Feel free to ask, okay? Because I love clearing the doubts, and I love mathematics as much as you do, okay? So it's fine, right? Okay. Shall we continue?
Yes, sir.
Okay. Now, what if the value is f 0.0000000001, right? This time it is greater than 0. Am I correct?
Yes, sir.
Okay, so this will actually be filled because at 0 also it is 1, right? So this is actually filled for now. Okay, fine, correct?
Yes.
Sure, no problem?
Yes, sir.
Because equal to symbol was here. Are we clear?
Yes, sir.
Okay. Okay, so what will be its value, Sandra? Can you tell me?
So 2.
Great, 2. So when we are very close to 0 but not on 0, it is coming out to be at 2. Are we clear? Are you understanding the plotting of the graph?
Yes, sir.
Is it being complicated?
No, sir.
Okay, great. So like that. Okay, so we got a graph, right? But what happened at this point 0, right? We had to lift our pen from one part to the other part, correct? What happened around 0? There a gap was formed. Are we correct? Right?
Yes, sir.
Sure. No doubt still now.
No, sir.
Okay, so there are no gaps till now. So there was a gap around 0, right? So what is this function continuous? No, right? It is a discontinuous function. Are you understanding a little bit of it?
Yes, sir.
Basically, in simple words, if we have to lift our pen around a point while drawing a function, while drawing the graph of a function, that function is discontinuous at that particular point, right? So this function is discontinuous at 0. Did we understand till here?
Yes, sir.
Sure.
Yes, sir.
Any doubts?
No, sir.
Okay. Shall we move to the next next part?
Yes, sir.
Okay, fine. So I didn't have the prior knowledge that you already have studied this chapter, so I would have been at a very fast rate. I still can, but it won't give you that much of fun, and you won't understand my style of teaching. So that's why I'm presenting it this way, right? So it's fine,
Yes,
right?
sir.
Just we are looking at the same things in a little bit of different attitude. Is it so? Like in comparison to your school?
So it's just, since it's school, so it's a bit mundane. So this is kind of nice.
Okay, fine, great. Okay, so we are going good till now, right? Okay, so now the concept of left hand limit, right? So we are aware about the concept of number lines, are we?
Yes, sir.
Okay, so suppose this is a point 1, this is point 0, right? If I say 0.0 or maybe let's take it more better way. Okay, where's my this? Okay, so zero, not let's not take 0 every time, and it will get tired. Okay, so we take 0.99999. It's very close to 1, isn't it?
Yes, sir.
Am I correct? It is very close to 1. It is somewhere around here, is it? Not to 1, but somewhere around there. Are you getting me? Right? Okay, but it to the left hand side of that. Okay, so we can denote it by limit x tends to 1 minus. Are you getting me? What is left hand limit? Are we clear with that?
Yes, sir.
Sure.
Yes, sir.
The number that is very close to the particular integer, but not exactly that. Okay, it is at the left hand side of that. Are we clear? Okay, now if we say 1.00000000001, right? Are we getting it? Are we understanding it?
Yes.
So it is slightly greater than 1. Am I correct? It is at the right hand side of the 1, and it is not exactly 1, right?
Yes, sir.
So were we able to understand that what is left hand limit and what is right hand limit clearly?
Yes, sir.
Sure.
Yes, sir.
Okay, we can see in this graph, right? What happened is, see, this was here is our left hand limit, right? So our left hand limit, are you getting me? The value of the function was not equal to the value of the function at right hand limit. Did we understand this, Sandra?
Yes, sir.
If I wrote it like this in particular, some kind of mathematics, were you able to understand this?
Yes, sir.
Did you understand this statement, whatever I have written over here?
Yes, sir.
Okay, great. So I'll surely ask the Philo team to like solve that issue as well, so that we can use the board of Philo platform only. Okay.
Yes, sir.
So we'll talk about that. Okay. Okay, fine. So we understood this much. Okay. Continuous function in simple terms. We have already discussed this, right? A function is continuous at a fixed point if we can draw the graph of the function around that point without lifting the pen. Are you getting me? Like around 0, what we had to do? We had to lift our pen. Are you getting me?
Yes, sir.
Right? But if we won't have to lift our pen, what will happen? We'll call it a continuous function. Okay. Shall we see an example?
Yes, sir.
Okay. Do you know what is this? What have I written over here?
Yes, sir.
Can you see, Sam? Yeah. Can you tell me? Can you explain me? I'm not testing you. Don't worry. I know you are pretty much aware about that. But yeah, just to make it a little bit more interactive, right? So can you tell me what is that?
So mod x, so it gives the positive value.
Mod x. Yeah, so basically it doesn't matter whatever value you give to this guy, he's gonna give you it in positive form. Am I correct?
Yes, sir.
Right? Where x can be anything, right? Am I correct? Its domain is real numbers. We know about domain and range, do we?
Yes, sir.
Great, Sandra. Okay. So what is gonna happen? So can I write it like this? So basically it is going to be minus x when my x is smaller than 0, and it is going to be x when x is greater than 0. Are we clear? Is it so?
Yes, sir.
Right. Am I making you speak too much, or is it
That's
fine?
fine, sir.
Okay, great. So this is our function, right? If we try to plot the graph for this particular function, right? Okay. I hope Philip whiteboard would have worked, because I don't want to draw this, I would say, zigzag lines, but fine. Okay. So again, x and y, right? Clear?
Yes, sir.
See, now we'll again check at point 0. So what is going to happen? Minus 4 it is, but it is going to give us the positive value of 4, right? Okay. When then minus 3, so it is going to give the positive value of 3. Am I going too fast, or are we fine?
Fine, sir.
Fine, right? So the graph is going to look something like this, and then like this, correct? At 0, it is at 0. Are we clear?
Yes, sir.
So this time my pen did not lift around 0, did it?
No, sir.
No, right? So is it a continuous function? Can I say that?
Yes, sir.
Okay, so now we are talking only in simple terms. We didn't use any mathematical terms. We just said in a function, okay, there are domains, right? So at a certain domain, right, if we are not lifting our pen around it, that function is continuous around that domain or around that element. Are we clear?
Yes, sir.
Sure, it is not getting too complicated. It is not getting over the head.
No, sir.
Okay, great. Okay, so shall we move to the next part?
Yes, sir.
Okay, again we have one more example. Okay, so I know I'm taking a lot of examples, and to trust me, I would say, take a lot of examples and do a lot of numericals, but I think that is how maths is done. Am I correct?
Yes, sir.
More practice leads to more better grasping of the concept, right? So we have again a thing in front of us. So it's very simple. I'll try to do it a little faster, okay, so that you don't get bored, because because when you're familiar with something, you kind of get bored. Okay, so what is happening at x? If x is equal to 0, it is at 2, right? And any value apart from x, this function is giving us 1. Are we clear?
Yes, sir.
Correct. Okay, what other subjects do you like, Sandra? Like, do you study computers as well?
Yes, sir.
And do you like it? Because there are logics and things. So if you are well aware about it, I can give you example from computers as well. No problem.
So I'm fine with anything.
Okay, great. So what is going to happen? It doesn't matter. -4, -3, -2, maybe 100 over here, whatever. What is going to give us? It's going to give us 1. Am I correct?
Yes, sir.
Right? So everywhere apart from this 0 point, it is going to give us the value 1. So have I drawn the graph correctly?
Yes, sir.
And at 0, what value is this function giving to us?
2, sir.
2. So somewhere around here. Okay, are we clear?
Yes, sir.
Right? So at 0, this is the point. Are we getting it? So again, at 0, I had to lift my pen. Am I correct?
Yes, sir.
Okay. See what happened. This time my left hand limit of 0, am I correct, was, okay, are you getting
Yes,
me,
sir.
was also equal to 1, correct? And right hand limit of 0, am I correct, that was also equal to 1, right? Am I correct or not?
Yes, sir.
Are we correct? Sure? Are we understanding it properly, Sandra?
Yes, sir.
Okay, and in any case, if I'm pronouncing your name wrong, right, please feel free to correct me, okay?
Sure, sir. Same. It's correct only.
Okay. Okay, sure. Okay, great. So we are getting left hand limit and right hand limit equal, but at function, the exact value of 0, we are getting something different. Are you getting me? Are we clear with this?
Yes, sir.
Are we understanding it properly?
Yes, sir.
Okay, great. So we understood this. Okay, so left, again, I have just written the same thing what I've explained right now. Okay, so left and right hand limits at x equal to 0, both are equal to 1, correct? Okay, but the value of the function at x equal to 0 is equal to 2, right? This is not coinciding with the common value at left and right hand limit. Okay, so we cannot draw the graph without lifting the pen, all that thing. Okay, so are we clear till here, Sandra?
Yes, sir.
You need a break, small 2 minutes break or something, or are we
I'm
fine?
sir.
I know you are a class 12 student, so better sitting capacity and better concentration, I hope.
Yes, sir.
Right? Okay. So now we talked a lot about lifting pen and all those things. Okay, so but we need to put it in mathematical terms. Come on, right? Okay. So what we learned, we're just gonna use that. Okay. So what we saw was, in order for a function to be continuous, right? LHL, left hand limit, its right hand limit, and the value of the function at that particular domain. All these three things should be equal. Are we correct?
Yes, sir.
Are you getting me? Sure. Did I go so fast, too fast or something?
No, sir.
Okay. So if the left hand limit, right hand limit, and the value of the function at x equal to c. What is c actually? See, suppose we'll take this example. Fx is equals to x square. Okay. So now the x can be element of anything, any real number, right? No problem with that. Okay. So this can be, and what is c? C is a subset of this real number, any particular element of this real number only. Okay, this c can be 2 or 3 or 4 or 5 or maybe 99 or maybe minus 99. Are we clear with this, Sandra? Are you getting me?
Yes, sir.
Okay, so this c can be anything like that. Okay, so now the value of, suppose my c is actually 3, so value of f3, this should be equal to the left hand limit of 3. Sorry, just a second, maybe undo would work. Yeah. Okay, and then fx, and this should be equal to the right hand limit. Is it getting too hectic or messy or something, or is it fine?
It's fine, sir.
Okay, so are we understanding it, right?
Yes, sir.
And in simple terms, and when we can say the limit is existing, when the left hand limit and right hand limits are equal, right? So in short terms, what we can say, we can just say that this is what is going to happen, correct?
Yes, sir.
Right? Okay, great. Right, so we are clear till here, right? No problem.
No, sir.
Did we understand it in mathematical terms properly?
Yes, sir.
Do you know continuity a little more better than what you were aware of 15 minutes earlier?
Yes, sir.
Okay, sure.
Yes, sir.
Okay, so that gives me a little bit of confidence. Okay, fine. So now let's jump to some questions. Come on, because mathematics, if we want solve questions, we are basically doing nothing. Am I correct?
Yes, sir.
Right. So check the continuity of the function fx equals to 2x plus 3 at x equal to 1. Okay. So we are going to do it mathematically. Okay. And then we will check our concept by plotting this graph. Okay. Fine.
Yes, sir.
Is it okay? Sure.
Yes, sir.
Okay. Okay. Great. So what are we going to do? First of all, x, we have to check the continuity at which point? At x equals to 1. Right. So let's
Yes, sir.
check the value of the function. Okay. So f1 equals to, can you solve it for me? It's so silly question to ask you, but so sorry, I'm asking you. Can you tell me the answer?
So 5?
Great. Okay. So we got f1 as 5. And what about limit x tends to 1? Do you know how to solve limits?
Yes, sir.
Can you tell me the answer?
So 5 itself?
5 itself. Great. So what is happening? The value of x very close to 1. Are you getting me? And the value of the function at 1, both are same. That means we are not lifting our pen. Are we correct? Are you getting me?
Yes, sir.
So hence this function is continuous. Can we say that?
Yes, sir.
Sure.
Yes,
Is my
sir.
handwriting so poor?
No, sir, it's pretty good.
Okay, not pretty good, but yeah, okay, it's fine. Okay, so let's plot this graph. Do you know about this website?
No, sir.
Okay, so I'll show you this website. This might help you in a long run as well. Just give me a second. Okay, just a second. So sorry. Is it going on Brave or something? I'm trying to open a new tab. Okay, I'll just do it in some other site. Can you hear me properly, right?
So I couldn't for like a bit in the middle.
Okay, but now you can hear me, right?
Yes, sir.
So just a second. I'm opening a site for you. Okay. Just a second. Okay, better I'll share that with you. I'm just stopping this PPT for a second and I'll show you something else. Okay, it's fine, right?
Yes, sir.
Okay, and here we are. Okay, so this site you can take a note of. Can you see the screen?
Yes, sir, I can see it, sir.
Okay, so the site is this. Okay, desmos.com calculator. Okay, so what was our function? Can you tell me?
So f of x is equal to 2x plus 3.
Okay, so instead of just fx, I wrote y, so that's fine. I hope, right?
Yes, sir.
Right? Okay, so y equals to 2x plus 3. Okay, so this is our graph. Can we see the graph? Are we able to see the graph?
Yes, sir.
Okay, so what is happening at which point we had to check 1, right?
Yes, sir.
Okay, so y equals to 2x plus 3. Okay, and so here is our 1. Am I correct? Just let me, I can't use pen over here, but this is 2, so this will be 1. Am I correct? Can you see my cursor?
I can't see your cursor, sir.
You can't see my cursor, right? Okay. Can we do something for this? Just give me a second. There should be some plotting or something. So sorry for that, but I'm trying to figure out something. Okay, never mind. Okay, so but you can see 0 and 2. I'll just zoom in for you. I think that's gonna help.
Yes, sir.
Okay. So sorry.
That's
Okay,
fine,
great.
sir.
So yeah. So this is 2, right? So this is gonna be 1, right? Okay. So at 1, this is a straight line. Am I correct?
Yes,
Right.
sir.
So we are not lifting our pen at any point. Are you getting me?
Yes, sir.
Right. So this is what I wanted to explain. So basically, this is a continuous function. Are we clear?
Yes, sir.
Sure.
Yes, sir.
Okay, great. So I'm gonna now let's get back at that only. Okay. So you can't see. Can you just let me just try once more? Okay. Are you able to see any PPT now? No, right?
So in the charts?
In the screen or something on the whiteboard, are you able to see?
So yes, sir. Now I can see it.
Can you see continuity and differentiability by Avinash Chaturvedi, something like that written on the board?
Yes, sir.
Okay, I think so. I think it takes a little bit of time to load for the students. Okay, next time I will keep it in PDF form, so maybe it will be better. Okay, so okay, I'm now like scrolling down the slide. So are you with me? Are you able to see that? Okay, great. So now I think I would be able to draw better graphs. Okay, fine. So till where did we reach, right? So we understood till here. We solved this question, did we?
Yes, sir.
Okay, so was this a continuous function?
Yes, sir.
Right, so this was a continuous function. Okay, fine. Okay, shall we move to the next question?
Yes, sir.
Okay, I'm so sorry. I'm what do you call? I'm making you bored by these very silly questions, but I have to do it. Sorry. It's fine, right?
It's fine, sir. It's fine. It's
Okay, so
totally
what we
fine.
have fx. Okay, so fx equals to x square. Okay, and where do we have to check the continuity at 0? Correct.
Yes, sir.
Okay, so what is going to be? It's going to be, we'll check the function value at 0, right? So this is going to be 0 itself. Am I correct? I'm trying to be a little bit faster now. Okay, so limit at x tends to be 0, and what it's going to be? Can you tell me?
So 0 itself?
0 itself. So is it going to be a continuous function?
Yes, sir.
Okay, great. Now I'm finally going to use the graph that I wanted to use from so long time. So sorry. So now I can actually do this on the Philo board. That is what I wished for. Okay, are you getting me? So
Yes, sir.
this graph is going to look something like this. If I'm not wrong, am I wrong? I'm no. It's gonna. Let me try to move it. Yeah, great. Okay. So it's gonna look like that. Am I correct?
Yes, sir.
Sure.
So isn't it supposed to be a bit pointy?
Yeah, it is supposed to be a bit pointy. Correct. Okay. So should I do that? Okay, I'll try to do that. Okay.
No, it's fine, sir. It's fine, sir.
Okay. No, I'll just try. No problem. Okay. Great. Oh, nice. Okay. So basically, we understood. I think we understood the concept of continuity way better. Did we?
Yes, sir.
Sure.
Yes,
Okay.
sir.
Again, a question. I have plenty of questions to be honest, but we are we going to do that? But this time you have to show that it is not continuous. Okay. So a little bit of variation. Fine. Will you do this for me?
Yes, sir.
Okay. Okay. You don't have a pen tab or something, right?
Sorry, sir?
You don't have any pen tab or something like this, right? Like you can't write on the board, right?
Sir,
I can
no,
grant
sir.
you permission if you want to solve on the screen only, but okay, fine. So yeah. So can you solve it for me?
Yes, sir.
Okay. And is the interface fine with you? Are you like familiar with the interface, like how to use it? Like chat box is there, a lot of things are there. Okay.
Yes, sir.
Okay. Just tell me, okay, why is it not continuous? That's all. Not a lot of things.
Sir, f of 0 is 1, but the left hand and right hand limit would be 3.
F0 is basically 1, but limit of when x is very close to 0 is?
Sir, 3.
Okay, sorry. And F0 is actually 1, right?
Yes,
You
sir.
said that, right? Okay, so right, this, right? So basically both they are not equal. So this function is discontinuous at x equal to 0. Am I correct?
Yes, sir.
Okay, great. So I hope we understood the concept, right?
Yes, sir.
Okay. And this we have already discussed by plotting the graph, right? We did it by plotting the graph. Am I correct?
Yes, sir.
We checked by plotting the graph, and we can do it mathematically as well. Shall we do it or shall we skip it?
So I'm fine with either, sir.
You feel fine with? Okay, let's skip one question at least. Come on, man. You are pretty good with maths, so I would like to skip one. Fine, right?
Yes,
It's not gonna be counted as my demerits, or is it that I'm skipping
sir.
questions? Okay,
No,
great.
sir.
So this is note, right? That constant. Okay, what are constant functions, Sandra? Can you tell me?
So the f of x is equal to a constant?
Yeah, fx equals to basically again some kind of a idiotic function that is gonna give you a constant value that is maybe 3, 4, or 500 or something. But at every particular, like, it doesn't matter what is x, it's gonna give us the value 3. Am I correct? Or maybe 4, right?
Yes,
Are
sir.
we clear? Sure.
Yes, sir.
This was your understanding as well, I believe, right? Am I
Yes,
saying
sir.
something wrong?
No, sir.
Okay, so and it's going to be continuous. It's very much clear, right? That it is so the graph is not moving at all, so it's going to be continuous. Am I correct?
Yes, sir.
Like this. Okay, so this was our x and y axis, and let me take a straight line. Come on, yeah. So fx equals to 3. So whatever value we doesn't care, it's going to be like this. Am I correct?
Yes, sir.
Right? Okay, now I can use colors as well. I feel very good. Okay, so I hope we are able to understand this concept. Are we?
Yes, sir.
Okay, and what are identity functions?
So f of x is equal to x?
F of x equals to x, correct. So what is how is it gonna look like? Can I draw that one as well over here? Is it gonna look something like this? Is it gonna look like this? The line?
Yes, sir.
The yellow line? Sure?
Yes, sir.
Okay, great. So is it also, it's also a continuous function? It's very much obvious. If we want to prove that, we can also prove that. Are we correct?
Yes, sir.
We can prove it mathematically as well. Am I correct?
Yes, sir.
Sure?
Yes, Yes, sir.
Okay, great. So do I need to prove it? Shall I prove it?
Some are alright with either.
You're all right with either. Okay, so this time I'm gonna just prove it. Just one. Okay, so basically constant function, right? So limit x tends to, okay, so whatever value we had, right? Okay, are you getting my point?
Yes, sir.
What we can say, like suppose limit x tends to c. Okay, we are assuming that c is a number. Okay, fine. And what is our function? Our function is fx. Okay, so it's anyways it's gonna give us k. Are you getting me? And fc is also going to give me k. Are we clear?
Yes, sir.
Sure, 100%.
Yes, sir.
Okay, great. Okay, yeah, fine. Okay, so now till now what we were discussing that whether a function is continuous at around a particular point or not. Are you getting what I'm saying, right? We were checking, if we just go back, we were checking whether it is continuous around this particular c or not. Are you getting me? It was whether continuous around, you know, 0 or not. Are you getting my point, Sandra?
Yes, sir.
Sure.
Yes, sir.
Okay, so but now we are going to discuss about whether the function as a whole, are you getting me? Like how we check on Desmos, right? There was a straight line, so that function is continuous forever. Are we correct? It is not going to be discontinued at any of its domain. Are we correct? Are you understanding what I'm saying?
Yes, sir.
Is it getting complicated, Sandra? Feel free to ask. No worries. Okay.
Yes, sir.
Are we clear? Sure.
Yes, sir.
Okay, great. So we were checking function is continuous around a certain point or not. Okay. Now we'll try to find out if a function is continuous as a whole or not. Are you getting my point?
Yes, sir.
Okay. So you know that already. Like what? Now I'll just give it. This is a theory part, and I'll also give an example. Okay, fine. So
Yes, sir.
basically, suppose there is a. Let's change the ink. Let's get back to black again. Okay. So yeah. So fx is equal to suppose anything 2x suppose, okay, but I suppose now x is an element from, I would say, 5 to 20. Are you getting my point, right? This is our domain. Are we clear with this?
Yes, sir.
Sure, this example is clear till now.
Yes,
Basically
sir.
fx equals to 2x and the domain is from 5 to 20. Okay, now so if this function needs to be continuous at 5, 6, 7, 7.1, 7.2, 19.1 till 20, at every point this function should be continuous. In order to it, we can call the function to be continuous. Are you getting me or not?
Yes, sir.
Sure. Am I going too fast? Do I speak very fast or something?
No, sir.
Okay, great. So we understand till here, right? That in order to prove a function to be continuous, that should be continuous at all of its points of its domain, correct?
Yes, sir.
Right? Okay, so that is what it is explaining. Continuity. You can see my pen cursor, right? At least, I think.
Yes, sir.
Okay, great. Okay. So continuity of f at a, like this point at 5 means, what does it means? That limit x tends to 5 plus. That is the right hand limit. Are you getting me? Of
Yes.
fx, it's gonna be equal to f of 5. Are you getting me? Okay, why not 5 minus? Because 5 minus, if I'll go out, so this will go outside of the domain. Are you getting me? So, so left hand limit is not making sense. Are we clear?
Yes, sir.
Sure, Sandra? 100%
Yes,
sure? Any doubts,
Yes,
feel
sir.
free to ask, okay? If you want to maybe understand it in a different word or in a different way, it's completely fine, okay? Fine.
Yes.
And the similar way at B, at the last point, only left hand limit is going to make sense because right hand limit will again get out of the domain. Are you getting me?
Yes, sir.
So did we understand this concept? In order to
Yes.
prove a function continuous, it should be continuous at all points of its domain, okay? So as a consequence of this definition, if f is defined only at one point, it is continuous there. If the domain of f is singleton, what is basically saying is, suppose I said fx is equals to 2x square, and I'm saying that my x is only, like I have given that the domain has only one set, x is equals to 2. Are you getting my point? So
Yes,
it's
sir.
obvious that this function is going to be continuous. Am I correct?
Yes, sir.
Sure.
Yes, sir.
Right? If this function is continuous at 2, this function is as a whole is continuous because only one point is there to check for us. Are we correct? Are we clear?
Yes, sir.
Sandra, you need a break?
No, sir.
Okay. I do have a break option for you. Not like that, like how would I say? You will see it yourself. Okay, fine, right? Okay. Just after some questions, we will discuss something outside the topic. It's fine, right? Mathematics only, don't worry. But yeah, okay. So discuss the continuity of the function fx equals to 1 over x at x not equal, and x is not equal to 0. That is already been given to us. Thank God, right?
Yes, sir.
So is it continuous or not, Sandra? So how are we going to check it? So we will suppose that basically at C, are you getting my point? C is one of the point in the domain. Clear?
Yes, sir.
Are we clear?
Yes,
This
sir.
is going to be equal to 1 over C, right? And FC is equals to 1 over C. It is clearly said that X is not equal to 0, right? Are you getting my point?
Yes, sir.
So this is going to be a continuous function, because if the 0 would have been there, right, then the whole scenario would have changed because our values won't match. Are we clear? Sure?
Yes, sir.
100%?
Yes, sir.
Okay, great. So let's move ahead. Are you getting bored?
No, sir.
Okay, so now what we understood the concept of 1 over x. Okay, what is 1 over x, right? So now that we have understood 1 over x, let's understand infinity here only, okay? Right? So see, when, are you getting right? This fx was 1 over x. Are we clear?
Yes, sir.
Okay, so have you, I think teacher might have skipped this in school, or did they teach? I'm very much interested
Didn't, sir.
in knowing actually. They didn't, right? Because yeah, people actually ignore NCRT, to be honest. My whole PPT is made from NCRT. It is very obvious, it is very clear. But NCRT, helps you in understanding the concept if you read it properly. Are you getting my point, right? I'll explain you something as well. Like, okay, I'll tell you what we are going to discuss in a break. We'll discuss why anything raised to the power 0 is 1. It's an interesting question, right? We mug up that 2 raised to the power 0 is 1, or anything raised to the power 0 is 1. But why is it so? Are you getting me? And one
Yes,
more
sir.
concept we're going to discuss is why is 0 factorial equal to 1? Okay, so these two concepts we're going to understand in a break. Okay, so basically just a little bit of relaxation from this calculus, and we'll do that as well. Okay, so before that, infinity. Okay, is it getting too much for your brain or something? No, right? Or yes?
No, sir.
Okay, fine. Okay, so fx equals to 1 over x. Okay, so what is happening? As my x value is 1. Okay, are you getting me? So I got fx as 1. Are we clear?
Yes, sir.
Okay, now see, it's very obvious. It is a positive fraction. Like how much my denominator will decrease, its whole value will increase. Are you getting me?
Yes, sir.
Okay, let me explain you in this way. 1 over 2, 1 over 4. Which one is greater?
So 1
1
over
over
2?
2 or 1 over 4? 1 over 2 is greater. Okay, and so so what happened is this value was greater, so it is getting, the whole thing is getting smaller. Correct? Are you getting my point? Okay,
Yes, sir.
in this case what is happening? Okay, so but this was numbers, I would say greater than 1. Are you getting my point? Now what is happening is I'm getting smaller than 1. Okay, so I'm getting more closer to 0. 1 over 0.3. Now what will happen? Are you getting my point, what I'm saying? Is it getting
Yes, sir.
confused? Are you getting confused or something?
No, sir.
Okay, so what I was saying is, as I'm, so 1 over 0.3, so the value of this increased a little. See, we got 3.333. Okay, more we are decreasing, more we are going near 0, it is getting 5. Okay, now we went 0.1, it is increasing more, it went 10. Are you understanding this sequence, Sandra?
Yes, sir.
Sure.
Yes, sir.
We are getting more closer to 0, more smaller numbers. 0.001, we reached 100. We are getting more closer, 0.001. Are you getting my point? We reached 1000. So if we'll go 0.00000, so we are reaching almost 0, and the value is increasing and increasing. Are you getting me? So we are assuming that if it will reach 0, it will be at its extreme position, and that is what? That will never be reached, and that is infinity. Did we understand some concept of infinity over here? That why is 1 over 0, why is it called infinity? Are we understanding this now?
Yes, sir.
Sure. Was it a boring
sir.
thing? Shall I
No,
have
sir.
skipped it? Sure.
Yes, sir.
Okay, fine. Since this was a demo class and we were not aware about like how your academic performance is, this I would appreciate that it's pretty good. But since I was not aware about all of these things, that is why this PPT and these things are like that. I'm completely adaptable. We can increase the speed and like more focus on the doubt solving and things like that. Okay, are you getting my point, right? What I'm saying? Okay.
Yes, sir.
So why is 0 factorial equal to 1? This was our break time that I had planned. Okay. So I think we have already been in around 42 minutes. I can see that. Okay. 42 and a half minutes in our session. And I think it's a time to discuss something else. Fine, right?
Yes, sir.
Any confusion till what I have taught till now? Please feel free to ask.
No doubt, sir.
No doubts? Okay, fine. Okay. So in order to understand 0 factorial equals to 1. Okay, what is 1 factorial? Can you tell
So 1.
me? 1. Okay. What is 2 factorial, Sandra?
So 2.
Fine. Just a little bit more. Have patience, as I said, prerequisites for the chapter. So 3 factorial
So 6.
and 4 factorial. Just a little bit more. Don't worry. I'm not going to give you complex calculations.
So 24.
Okay. Let's just last one. I'm 100% sure it's last one. 120, right?
Yes, sir.
Is it? Okay, fine. Okay. So see, what happened? 120 got divided by 5 and we reached 24. Okay, correct?
Yes, sir.
Right? Then 24 which was 4's factorial. It got divided by 4 and we reached to the factorial of 3. Is it?
Yes, sir.
Then 6, which was factorial of 3, it got divided by 3 and we reached 2. Did we?
Yes,
And
sir.
2, which was factorial of 2, it got divided by 2 and we reached 1. Then 0 factorial, so with 1 which is factorial of 1, it will get divided by 1 and 0 factorial would be equal to 1. Did we understand this concept now? There is no
Yes, sir.
other thing that 0 factorial can be. Because maths is, sequence and series. AP, what is it about? It is about patterns. It is about sequence. So are you getting my point? Why is 0 factorial equals to 1? It can't be anything else. Are we clear?
Yes, sir.
Sure. Was it fun?
Yes, sir.
Okay. And just one more. Is it fine or am I, if I'm what you will call? Sometimes I the word is in my brain, but it doesn't come on my mouth. How to put it? Am I making you fed up or something? That is what I want
No,
to
sir.
ask. Sure.
Yes, sir.
Okay, fine. So 2 to the power is 0 equals to 1. Why? Or maybe 3 to the power 0 equals to 1. Why? Okay. Okay, so what is 2 to the power 1? 2, right? 2 to the power 2, 4. 2 to the power 3, 8. 2 to the power 4, 16. Correct? 3 to the power 1, 3. 3 to the power 2, 9. 3 to the power 3, 27. Correct?
Yes, sir.
Right? Okay. Just go with a similar pattern. God divided by 2 reached 8. God divided by 2 reached 4. God divided by 2 reached 2. Will get divided by 2 and will reach what? 1. Correct. And what will it be? 2 to the power 0. Right? Similarly, 81. God divided by 3 reached 27. God divided by 3 reached 9. God divided by 3 reached 3. Will get divided by 3 and will reach where? 1.
So 1.
Are you getting me? Yeah. So this is the pattern. Are you understanding now why 2 to the power 0 is equals to 1 or why 3 to the power 0 equals to 1? Are we clear?
Yes, sir.
Sure. I just found it. It's not my own concept. Come on. I also found it somewhere on YouTube. Found it interesting. So just got it over here. Okay, fine.
Yes, sir.
Fine. I am glad that I had it because, continuity, you are absolutely mastering it. So how will I flex that I knew something that you didn't, right? So, okay. So again, we have some questions. Discuss the continuity. We have already been 46 minutes into the session, right? So how many questions do you have? I just go through the PPT, okay, for you, okay? So this is also find all the points of discontinuity, fine, right? And let's look. And I had planned to look in the rest of the examples from NCRT because we won't miss any question. Don't worry on that, okay? Fine.
Yes, sir.
And then I had theorem. So I had planned till exercise of basically, what was that? Sixth or whatever, 7th chapter it was, 7.1. Are you getting my point? What I'm saying, right?
Yes, sir.
So I had prepared till there, for use, PPT. So a little better. Instead of reading line by line from NCRT, then doing the examples, just make it a little bit shorter. Am I correct? Right? So shall we do just 1 or 2 more questions and will it be fine for today?
Yes, sir.
As a demo class? Sure?
Yes, sir.
Okay. So discuss the continuity of the function f defined by x plus 2. Okay, so basically we have to check whether this is a continuous or a discontinuous function. Sandra, all over to you. You're going to tell it for me. Fine?
Yes, sir.
It's not that I'm bored or tired. Don't worry, I am not. But I actually want you to just tell me. Okay, so I would be able to understand how good you are in academics. I already know now, but still.
Yes, sir.
please don't go through the NCRT because it's actually an example. We can clearly see that, but yeah, we're gonna solve it today by ourselves. Okay?
Yes.
I know you're not gonna do that, but yeah. Okay, I'll also try to solve. And I know you will reach answer quickly than me, but I'll still try. Okay, better let me erase this. Or okay. Are you there, Sandra?
Yes, sir.
Okay, are you solving it?
Yes, sir.
Okay. You're familiar with the chat, right? You can also send the picture of whatever you have solved in the chat box. Okay, you can do all such things, just like how you do in WhatsApp. Okay, you can send the attachment as well. Okay, are we clear?
Yes, sir.
Right. In case you are not clear with the interface, feel free to ask. I can help you with that as well.
Yes,
Okay?
sir. So I'm actually on a PC, sir. So take me like a minute
Okay,
to
it's fine.
send
It's
it.
completely fine. It's completely fine. No problem. You can just tell me if it was continuous, and if it is not continuous, why is it not continuous? That's all. Okay. Are you able to understand it, right? No
So,
problem with that. Am I correct?
yes, sir.
Yeah.
It's
Yeah.
continuous at all real numbers except one.
Yes, exactly. It is continuous at all real. And what is happening at one, Sandra? Can you tell me?
So it will be 3 and minus 1, sir.
Okay, 3 and minus 1. Okay, but at like see, at left hand limit, right? When it is less than 1, are you getting my point? What I'm saying, right?
Yes, sir.
What is going to happen? So this is going to be at left hand limit. It's going to be, I would say, let's give me a second. At left hand limit of 1, it's going to be 3 only. But the problem is happening where? At the right hand limit. Are you getting my point?
Yes, sir.
Sure.
Yes, sir.
What is happening over here? Here it is going to be 1 minus 2, that is minus 1. Okay. So f1 and left hand limit are limit, but left hand limit and right hand limit should be equal, as I said earlier, right? So that is why it is getting discontinued at 1. Okay. And rest of the point it is
Yes,
continuous.
sir.
Are we clear, Sandra? You're pretty much good with the concept. I'm happy for that. Okay. And I think okay. So how many questions are left? I think only one question, and then we can go to the theorems, right? So is it enough for today for a demo class?
Yes, sir.